Good evening to all. I chosen a topic e-commerce analysis is here problem statement profitability. Analyze an e-commerce dataset to understand and predict profitability across different product categories and customer segments and identify key trends. Examine trends and patterns in the data such as monthly variations, most sold products and category-wise performance and clean the data and pre-process. Address missing values, duplicates, and outliers in the dataset. Next, convert and extract relevant data information from date columns. Explore relationship. Investigate relationship between features such as sales, quantity sold, discount, and shipping cost. Then, predicting profit. Build and evaluate regression models to predict profit based on selected features. Model performance assessment. Compare different models such as linear regression, discussion trees, and a random forest. Evaluate model performance using metrics like mean squared error and R squared. Derive insights. Generate insights into factors impacting profitability and provide recommendations to optimize operations and improve profitability for the business. Data collection. Data collection is a crucial step in any data analysis or machine learning project. It involves gathering relevant data from various sources to be used for analysis and model training. The data contains US e-commerce records 2020. For dataset, click here. Here is a dataset in my GitHub repository. You may download it here. Then existing solutions. The existing solutions involved established methodologies and approaches that data scientists and analysts to process, analyze, and model data efficiently. The solutions build upon years for research best practices in data science and analytics. Here proposed solutions. Here first, data cleaning and pre-processing. Remove missing values and duplicates from the dataset. Convert data columns to appropriate data types and extract relevant information such as month and the day of the week. And normalize numerical columns and handle outliers for better model performance. And insights. Based on the analysis, derive insights into the factors that have most significant impact on profit. Provide recommendation for the e-commerce business on how to optimize their operations to improve profitability. Then, exploratory data analysis. Create data visuals such as histograms, box plots, scatter plots, and heat maps to explore relationship between different features. Identify top selling products and categories as well as category wise and monthly variations in sales and quantity. Then, model building and evaluation. Split the data into training and testing sets. Train different regression models. Example linear regression, k nearest to neighbors, decision factors, decision trees, random forest on the training data. Evaluate model performance using metrics such as mean squared error and R squared. Then compare the performance of the different models to identify the best model for predicting profit. First, import necessary libraries for this project. It contains the NumPy and Pandas, Sigmod and Matplotlib. For sklearn for train the data model data. Then load the data. Here I have uploaded the data is here. Then I load it and I want 10 rows of the dataset. So I call the head, then tail, bottom of the dataset, then shape and the info. Means the data are presented in the datasets. Then data cleaning and pre-processing. In this process, we identify category and numerical features. These are the category features. Then numerical features are row ID, postal code, and such things. Then print we want a category wise. We have unique values, and then remove unnecessary columns. Then removing unnecessary columns, the data set will display here. Then order date convert time to month and day week. We want to categorize the day order date into month and day of a week, and we replace the numeric value because we want to represent month 1 January such things to Feb something. Then state codes mapping. Then after the state code mappings, the data types will be uh, displayed here. And finding the duplicate rows. The duplicate rows are duplicating rows. The rows remains 0. Those the 0, 19. And remove duplicates. Then insights. Insights of pivot table analysis. In the top 10 most sold products and categories. Here the table for this. And the visualizations like this. We have the flowchart for this. From the high value to low value in that descending orders. Then categories. We have taken office supplies and furnitures and technologies. Then we have to visualize a pie chart view for this office supply, furnitures and technologies. Then subcategory wise. Subcategory wise we have listed here and subcategory pie chart here. There are a number of subcategories. There are categories, binders, paper, art, furnishing. There are represented in the code. Then monthly total quality sales. Then total sales by month. Line plot. From the sales, total quantity of sales in the year of 2020, we have Jan to December. Then monthly total quantities change of categories. Here the table for this. Then create support for monthly quantity change of categories. Then we have to go for visualizations of furniture and office supply technologies for monthly quantity change in categories. Here is this. Then I used 5 types of visualizations. One of this and a violin. Violin for this for a simple attractive view of this. Attractive view and discount density 5 buns. Here is also same violin. Violin visualizations for discount density by segment for consumer, house office and corporate. Then total office. Total office supplies quantities by month by normal import. Then total furniture quantities by month. Here we also notice by month. Then total technology used by month. Here is the plot and quantity change in states and categories. Here is a table for this. Change in the table for this content and create a subplot for quantity change by states and categories. Make a subplot for it and take trace and visualizations process for this furniture, office supplies and technologies. For the state wise, California, New York, Texas, or some others. And handling missing values. We want to handle missing values for the data sets. Here the missing values is set as long as some. Then the missing values here all are all are at 0. So we have no missing values. And the handling missing values discount on sales. Then after that handling missing values, the data set make this and normalizing numerical counts. Numerical columns are normalized after the normalized column. Here is the table, and we want to calculate correlation matrix for numerical columns only. Here is the index for the numerical columns and table for it, and plot plot a heat map for a column matrix. Basically, column matrices are displayed heat maps. So I have displayed here as heat map and direct handle outliers in numerical columns and identify numerical columns. So I have this here and handle outliers in numerical columns. After handling, the dataset of the table is present here. Next, exploratory data analysis, such as EDA. Created data visualization I have already told. There are I used five types of data visualization. One is histogram for numerical columns, then box plot. They all are contains numerical columns such as quantity, sales, discount. Here is a volume plot, discount, profit, and a scattered plot for sales and profit, and a strip plot for quantity and sales. Here, here is a volume plot is different color I have used before I did on the code. Then scattered plot and strip plot. Here is a strip plot again for this quantity and sales. In the above, this is scattered. Then model building and evaluation. And we use the linear regression for this model building for MSC, such as mean squared error and R squared. We have to use this target variable X selected as X, sales, discount, and quantity, and Y as profit. So Y is our input. Sorry, Y is our output. X is our input. Then X is the table represented, and Y is table is represented. Y is the profit. Then we want to split the data for train and test. For extrain data shows here, X tested data shows here, then Y train data shows here, then Y test data shows here. Then we want to define models, linear regression KNN models, decision tree models, random forest models. Then we have to train the evaluated models and create a data frame for it and plot performance different models. Here I used bar plot for MSC and R square. Then these overall results are shown here. The top 10 most sold products is table and the category is percentage total quantity. Here is displayed and monthly trends in sales and quantity. Here is the table. Then quantity changes by the state and category and the model performance summary. Here is the last output for us. Here is the performance model summary. Then is the code is over. The final result is here. More performance result is the code outputs a data frame containing performance metrics that has MSC and R squared for each model. The bar plots in the last section of the code shows performance comparison among the models. And findings, we have find it in the models. The model with the lowest mean squared error and the highest R squared error, likely the best performing model from the given data. Random forest is often a stronger performer for regression tasks due to ability to handle non-linear relationships and complex interactions between features. Here, here the conclusion for this project. Based on the performance metrics, you can choose the best model and predicting profit in the e-commerce data. Additionally, analyzing the turning would be conducted to further optimize the chosen model. The overall, the workflow, sorry, the overall, the workflow provides a comprehensive approach to data analysis and modeling, including data cleaning, responsive, sorry, exploratory data analysis such as EDA and model evaluation. Adjustments and additional steps can be made based on the specific process goals and requirements. Here's the process is over and thanking you. So bye.